If 2025 felt like the year humanoid robots started showing up in the headlines, 2026 is shaping up to be the year they try to actually do work in the real world. I'm going to walk you through 13 humanoid robots that matter, not just hype machines, but the bots that have the hardware, the software, the money, or the real-world deployments to change industries. So welcome back, guys. Alfie here with top 13 AI humanoid robots that will rule 2026. You're watching the AI Nexus, and as always, we're here to bring you every step of the future. Let's go. First up, Tesla Optimus. You already know the name. Tesla has pushed Optimus into the spotlight as a mass manufacturing play. Their promise is simple and terrifying to some. Build humanoids at scale to handle dangerous or boring work. Tesla has talked publicly about moving Optimus from prototype into pilot production, and then into factory floors in increasing numbers. That's huge because Tesla has the manufacturing muscle to actually try to make robots in quantity, which is something most robotics startups only dream of. But the road isn't smooth. There have been leadership changes, design reworks, and skeptical press about meeting ambitious unit goals. Still, whether Tesla falls short of the most breathless timelines or not, the fact that one of the world's largest manufacturers is pouring R&D and factory know-how into a humanoid program means Optimus will be at the center of the 2026 conversation. Next, Figure's lineup deserves its own spotlight. Figure's FEO2 already gave the world a glimpse of humanoids doing dexterous tasks. Think sorting, fine manipulation, and operations in constrained home-like spaces. And the company's roadmap for a production-ready Figure 03 is one of the most aggressive commercial plays out there. The CEO has signaled that F03 is walking, and that Figure intends to move fast on hiring and production ramp. Between impressive dexterity demos and very public plans to ship at scale, Figure is arguably the biggest challenger to Tesla in the humanoid arms race. If Figure nails reliability, price, and safety, its robots could flood logistics and retail in 2026 and beyond. A mecha occupies a very different but equally important part of the ecosystem. Engineered Arts built a mecha to be the face of robotic-human interaction. It's not here to lift tons or run a warehouse. It's here to talk, emote, and interact in public-facing roles, museums, events, reception desks, and experimental care settings. A mecha's uncanny facial expressiveness and conversational capabilities make it the social humanoid everyone points to when they talk about what robots will look like in public spaces. In 2026, expect a mecha and platforms like it to be the first humanoids people actually meet in everyday places. And that will accelerate both fascination and debate about trust, privacy, and ethics. Boston Dynamics Atlas is a special category. It's the gymnastics superstar of humanoids. Atlas keeps pushing the physical limits of what a bipedal machine can do, running, balancing through rough terrain, and executing complex whole-body maneuvers. Boston Dynamics has been steadily migrating those skills into more robust perception stacks and real-world motion policies, often partnering with companies like NVIDIA to give Atlas stronger on-robot vision and decision-making. Atlas isn't the cheapest bot you'll buy, but in 2026, it will likely be the one you see used for disaster response, research, and demonstrations of how fast a humanoid can actually adapt in an unpredictable environment. When headlines talk about humanoids doing parkour or rescue work, Atlas is the reason. Agility Robotics Digit is the pragmatic sibling in this group. Digit has been designed for logistics and warehouse support. It's compact, purpose-built, and already field-tested in real facilities. The company has been improving its battery life, safety features, and integration with existing warehouse automation systems, which means Digit is the kind of humanoid that employers might actually bring onto a shift to handle repetitive tasks that weren't worth automating before. In 2026, Digit will be in workplaces where reliability and standards compliance matter more than flashy demos. Unitree is another name to watch because of how it scales lower-cost robotics. Unitree's move into humanoids, with G-Series teasers and more affordable platform goals, could democratize access to full-size humanoids. Think the difference between luxury, research-grade robots and affordable, serviceable humanoids that smaller businesses can buy. If Unitree hits aggressive price and supply targets, they'll be the company forcing the market to reckon with what happens when humanoids stop being curiosities and start being tools you can actually budget for. Neura's 4, Any1 Gen 3, and similar next-gen humanoids are important for a different reason. They represent the commercialization and safety-first approaches that regulators and enterprise buyers demand. When a platform like Neura emphasizes safe, predictable behavior and developer tooling, it becomes the backbone for mission-critical deployments, hospitals, elder care, and controlled industrial settings where human safety and fail-safes are non-negotiable. The robots that rule 2026 won't be the ones that are fastest to market. They'll be the ones enterprises can trust to behave predictably day in, day out. Fourier GR series, GR3 and siblings pushes the care-centered social companion angle. Fourier Intelligence's GR line focuses on emotional interaction, multimodal sensing, and approachable design for elder care, classrooms, and service venues. These robots trade industrial strength for relational intelligence, tactile sensing, attention to expressive cues, and LLM-based dialogue tuned for empathy make the GR series a likely candidate for real social deployments in 2026, especially in Asia where Fourier has strong commercial channels. UB Tech Walker S2 is UB Tech's next-gen service humanoid aimed at retail, hospitality, and consumer applications. Walker S2 continues UB Tech's focus on safe, user-facing interaction, along with improvements in robustness and autonomy. UB Tech leverages a global market reach and experience building humanoids for education and entertainment. Walker S2 is the company's move to bridge those strengths into more functional, serviceable bots. 1X Neo is an emerging platform focused on embodied intelligence. Tight integration of perception, manipulation, and planner stacks that leverage large multimodal models for real-time decision-making. 1X's research emphasis on real-world task transfer and a modular developer toolkit positions Neo as a contender among humanoids that must interpret messy human environments and make safe, context-aware choices. Apptronic Apollo is an industrial-grade humanoid designed around safety and human-robot collaboration. Apptronic's approach blends high-torque actuation with compliant control so Apollo can assist on manufacturing floors without sacrificing predictable interactions. Apptronic's emphasis on reliability, maintainability, and collaborative behaviors makes Apollo attractive to enterprises that need humanoid dexterity in structured production lines. Engine AI PM01, the developer's dream. In 2026, Engine AI's PM01 could rule the research and startup scene by becoming the affordable Boston Dynamics for humanoids. Its open-source ROS platform and plug-and-play AI chips make it incredibly adaptable for universities, robotics labs, and hobbyists who want to build custom capabilities without starting from scratch. The fact it's already agile enough to perform flips means it's well-positioned for complex, real-world physical tasks in factories, logistics hubs, and even entertainment. Limex Dynamics Oli, the modular workhorse. Oli could dominate 2026's commercial robotics market thanks to its modular hardware ecosystem. Imagine warehouses swapping hands for grippers, schools using expressive arms for teaching, or hospitals fitting advanced sensors for patient care. With high agility, balance, and pricing that's far below premium humanoids, Oli can scale faster into multiple industries. Something expensive robots like Tesla Optimus may take longer to achieve. Tiangong Robot, the Endurance Champion 2026, might be the year robots stop being demo-only and start working all day, and Tiangong Ultra is proving it. Completing a 21-kilometer half marathon without mechanical failure shows it has the stamina for patrol, delivery, and search and rescue over long distances. In environments where uptime is everything, security, outdoor inspections, or even disaster zones, Tiangong's endurance will make it a top contender. And that's wrapped up. The 13 robots I'd personally bet on influencing 2026 include the big-name manufacturers with production clout, the startups with best-in-class manipulation demos, and the social platforms with the most realistic human interaction. All of them will push one another. Tesla's scale talk will force competitors to think manufacturing first. Figure's dexterity will raise the bar for manipulation. Ameca will shape public expectations of what social robots should feel like, and Atlas will continue to redefine the athletic limits of humanoids. So that's the lineup of humanoid robots I think will shape 2026 in the real world. But here's the twist. The next leap for these machines might not come from more powerful motors or better batteries. It might come from a place you can't even touch. A fully simulated reality where AI can live out years of experience in just days. And Google's DeepMind just dropped something that could make that possible. It's called Genie 3, and people are already calling it the AI Matrix. It's a portal into a whole new reality. This thing can literally take your words and build an interactive, consistent, dynamic world. In real time. Yeah, you type it, Genie 3 makes it real. Like a game engine powered by your thoughts. But here's where things get even crazier. This isn't just for fun and games. Genie 3 is being positioned as a next-gen training ground for humanoid robots. We're talking about fully embodied agents learning in high-fidelity, physics-consistent, evolving simulations. This could be the system that finally gives robots a true childhood to grow up in, learn safely, and become world-ready faster than ever before. And just when you think we're done, no, the plot thickens. Because once we dive through the Genie rabbit hole, we're going to shift over to Astrobot, who just announced their new AI robot development suite. A complete vision-language action loop that lets researchers iterate and deploy robotic intelligence in the real world faster than ever. We're talking plug-and-play AI training with real hardware, natural teleoperation, and validation all baked into one sleek platform. So welcome back, guys. Alfie here with these two major updates. If you've ever wondered how we go from today's humanoid prototypes to fully functioning real-world AI assistants, buckle in. This episode's gonna connect those dots, and it all starts with Genie 3. Let's go. So, what exactly is Google Genie 3, and why are people calling it the Matrix? Well, it's the third iteration of Google DeepMind's Genie world model. And while the earlier versions were impressive, Genie 3 crosses a line into full interactive video generation, driven purely by text prompts, mouse movement, or even controller inputs. Imagine typing a futuristic city made of glass with flying robots and moving walkways, and immediately getting a high-quality animated world you can move through, influence, and interact with. No level design, no pre-programmed characters, just the AI filling in every detail procedurally from scratch and remembering what it built. That memory part is key. Genie 3 doesn't just create visual content, it maintains visual consistency for over a full minute. That means if you turn around, the house you passed a while ago is still there. Objects don't just disappear. Worlds persist, like they would in a video game engine, except this isn't scripted. It's imagined by the AI. And here's where your jaw might hit the floor. Genie 3 isn't using traditional graphics pipelines. It's not Unity or Unreal. Instead, it's using a causal, token-based world model. Think of it like GPT for physics-based video. It treats every frame, every object, every movement as a prediction problem, stringing them together with learned consistency. This is how it can generate rich, open-ended environments that still obey the laws of physics. We're talking about a system that doesn't just make stuff look cool, it makes it function believably. Okay, but what does this mean for robots? Everything. Because one of the biggest bottlenecks in training humanoid robots isn't the hardware, it's the learning environment. Teaching a robot to walk, navigate, use tools, or react to unpredictable changes in real time requires tens of thousands of hours of experience. But letting that happen in the real world is dangerous, expensive, and slow. That's why researchers use simulations. But even those have limits. Most current robot training simulators are static, brittle, or require tons of manual design. You get clean, lab-like scenarios, not messy, chaotic, real-world challenges. Enter Genie 3. This could be the training sandbox robots have been waiting for. Because Genie 3 lets you dynamically generate any scenario. Want your humanoid to practice in a bustling kitchen with slippery floors? Boom! Need it to learn to navigate an unfamiliar warehouse with low lighting and obstacles? Done. How about learning to work alongside humans in a hospital setting with unpredictable noise, movement, and emergencies? Genie's got it. What we're looking at here is the foundation of sim-to-real transfer done right. Because Genie simulations don't just look real, they operate with temporal coherence and physics-informed dynamics. And that's exactly the kind of learning environment where embodied AI, meaning robots with a physical presence, can develop high-level behavior without breaking things in the real world first. Let's talk about visual memory, because this is where Genie 3 destroys everything else in the category. Most video generation models can give you a few seconds of consistent footage before things go off the rails. Genie 3 gives you over 60 seconds of coherent world building, with entities that remember where they are and what they were doing. That's the equivalent of giving AI a working short-term memory, and it's absolutely essential for robots. Why? Because if you want an agent to plan long-horizon tasks, like cleaning a room, assembling a machine, or assisting in a complex medical procedure, it needs to remember context across time. Genie's ability to generate and maintain consistent scenes isn't just eye candy. It's a training revolution. It means an agent can practice multi-step tasks without having the world shift around it arbitrarily. And that unlocks smarter, more strategic learning. Now this might sound familiar, because this is the holy grail of world modeling. And DeepMind has been heading in this direction for a while. But Genie 3 is different because it's interactive. This isn't a passive video generator. You can give it real-time control input, keyboard, mouse, even game controllers, and it responds. That's a game changer, literally. We're talking about a general-purpose simulator that doesn't need to be built level by level. It builds itself as you go. That unlocks new possibilities not just for robots, but for AI agents, virtual assistants, gaming NPCs, training environments, and beyond. And here's a big one. Genie 3 is modality agnostic. It's not just taking text and outputting video. It's integrating input from vision, language, action, and planning, and using that to maintain control over evolving environments. In simpler terms, this thing can understand, react to, and build around your behavior. It's like ChatGPT crossed with Minecraft, but instead of blocks, you're crafting entire simulated universes. Now let's be real, Genie 3 is still in research. DeepMind hasn't released it to the public yet, and for good reason. The implications are massive. This kind of technology could be used to revolutionize education, training, robotics, gaming, remote collaboration, and even psychological testing environments. But it also raises big questions about what's real. If Genie 3's worlds become indistinguishable from reality, and robots start learning in them, we're entering a future where virtual and physical lines blur, where simulated experiences carry weight, where your AI assistant could have lived 1,000 lives before ever entering your kitchen. We're talking about an AI matrix, not one to trap us, but one we create to train the minds of our future machines. And that brings us to the next frontier. While Genie 3 is building the simulation, Astrobot is bridging the gap to the real world. They just announced something called the Astrobot Suite, and it's basically a one-stop shop for AI robot development. Think of it as a closed-loop ecosystem that covers everything from perception to action to validation. Here's the idea. AI researchers need to constantly iterate between models, hardware, and real-world testing. But that process is slow, fragmented, and error-prone. The Astrobot Suite solves that by combining a high-performance robot platform, a full teleoperation pipeline, vision language action modeling tools, real-world testing, and feedback loops. This means researchers can design a model, test it in simulation, run it on a real robot, validate its performance, collect more data, retrain, and repeat the cycle without leaving the suite. It's rapid iteration, optimized. And this matters because modern robot intelligence doesn't come from pre-programmed behavior anymore. It comes from learning, reinforcement, trial and error, multimodal data, and massive iteration. The Astrobot Suite makes that scalable. But what really sets Astrobot apart is their focus on teleoperation. You can literally control the robot remotely, capture human demonstrations in high fidelity, and use that to train or fine-tune your AI models. This is huge for vision language action models, the kind of AI that understands what it sees, reads, and hears, and uses that to act in the world. By turning human intuition into training data, and by letting that loop run faster than ever, Astrobot isn't just building smarter robots, they're helping the entire field move faster. And let's not forget, Astrobot already stunned us earlier this year with Astrobot S1, a human-sized robot with smooth motion, lightweight design, and dynamic AI control. The new development suite plugs right into that, meaning everything we saw in the lab can now be iterated on in weeks, not years. So let's tie this all together. On one side, we've got Google's Genie 3, building the Matrix, a fully interactive, physics-aware, memory-capable world model for training robots before they ever take a real step. On the other side, we've got Astrobot, giving us the hardware, control interfaces, and development tools to bring those AI minds into the real world faster than ever. This is the future of AI robotics, a seamless end-to-end intelligence pipeline from simulated experience to physical action. It's not just about building smarter robots. It's about building them faster, safer, and with a better understanding of our world. The lines between training and deployment, between virtual and physical, between imagination and embodiment, they're all blurring.